All right, so in this video, we will solve the partial differential equation given by 3 partial of u with respect t equals to 7x partial of u with respect x, subject to the condition u of x 0 equals to 5x to the 11th power. All right, so we'll solve this PDE using separation of variables. And again, for this, we're going to assume a solution of the form u equals x of t, which is the product between a function of x and a function of t, right? And well, so we're going to take the necessary partial derivatives as required in the PDE. That is the partial with respect to t, which is where f remains constant and g becomes g prime, and the partial of u with respect to x, that is equal to f prime because that's a function of x, and in this case g remains constant, remains itself. So substituting into the PDE, we obtain 3 f g prime equals to 7x f prime g, right? Well, the trick here again is to divide both sides by fg. That's going to leave us with 3 g prime over g equals to 7x f prime over f, right? Well, actually, I'm going to keep I'm going to move all the constants to the g side. So that is going to be 3 over 7 g prime over g equals to x f prime over f. And at this point, we have separated the variables. Well, so that means we're going to split in the problem into two additional differential equations. And for this, we will need a separation constant that we're going to call it k. All right, so let me solve the first equation. So the first equation, I'm going to replace d prime with dg. Well, let me write the equation again. 3 over 7 g prime over g equals to k. And we solve this equation, then we're going to solve the second equation. So that'll be 3 over 7. This g in the denominator means 1 over g times g prime, which is really dg. And in this case, g is a function that depends on time, on t, right? dg dt, which equals k. All right, so I'm going to separate the variables over here. So that's going to leave us with dg dg over g, really. And I'm going to multiply both sides by dt and also multiply by the reciprocal of 3/7, which is by 7/3. So that's going to leave us with 7 over 3 k dt. And at this point, we should be good to go and integrate both sides of the equation. That's going to leave us with ln of g equals to 7/3 kt plus some constant of integration that I'm going to call c. And again, I'm going to exponentiate both sides to get the g by itself. That is, g equals to e to the 7/3 kt, and again, e to the c is simply c, right? So we just obtained the g function. Now let's repeat the process, but now for the f function, for which separated the variables like x f prime of f prime over f equals to k. So number one, I'm going to rewrite this f prime notation. I'm going to call this x times this f in the denominator is 1 over f, and this f prime is the same as saying df dx. Again, recall that f is the function that depends on x, right? That's the what we call the spatial equation, as opposed to the temporal equation, which is the function that depends on time. And let that be equal to k. All right, so separating the variables, I'm going to multiply both sides by dx and divide both sides by x. Okay, so that's going to leave us with df over f equals to k k over x dx. And integrating both sides, that's going to leave us with df, the integral of df over f, which is ln of f, equals to the integral of a number over x, that's simply the number, ln of x, right? And then plus another constant of integration, but because we already used the letter c, I'm going to use another letter, letter d, right? Okay, so to solve for f, let's exponentiate both sides of the equation. And that's going to leave us with f equals to, on the one hand, e to the d, it's another constant, just d. However, you might want to cancel the exponential with the logarithm. However, we cannot do that just yet. For this, we need to have the coefficient of the natural log to become the exponent of the argument. That is, so we don't have anything in between the exponential and the logarithm. That's going to leave us with d e to the ln of x to the k. All right, that's f equals to, boom, cancel, d x to the k. And we just obtained the two functions that will form the solution to the general solution to the PDE. That is u of xy equals to big F of x, big G of t equals to dx to the k times, actually I'm going to start with the time function first. C e to the 7 over 3 kt times d x to the k, right? And again, you might want to absorb these two constants c and d. That is u of x y equals to a. This time I'm going to start with the x first, x to the k times e to the 7/3 kt. And this is our general solution, right? So now we will find the particular solution subject to the condition, again, given at the top. U of x sub x0, x comma 0 equals to 5x to the 11. All right? So let's see. So with u of x0 equals to 5x to the 11, that is u of x 0. This means we're going to go to the general solution, and for every instance of t, we're going to replace with a 0, that is a x to the k e to the 7/3 k times 0, which is equal to a x to the k, because k times 0 equals to 0, times 7/3 is also 0, so all of this goes to 1, all right? So all of this goes to 1, and 1 times ax to the k is simply ax to the k. So, and u of x 0 equals to 5x to the 11. With all this, okay, we can already equate coefficients. That is, in this case, this tells us that a equals to 5, and also this tells us that k equals 11. Let's write that down. So a equals to 5, and k equals to 11. So we may go ahead and write the particular solution to the differential equation. That is u of x y equals to a, which is 5, x to the k, which is 11, times e to the 7/3 times k, which is again 11, t. And simplifying this should give us u of x y, not ux y, uxt, by the way, u of xt equals to 5 x to the 11 e to the 77 third t. Final answer.